Welcome. In this lecture, I want to go through how all of these things fit together, like your position, your velocity, your acceleration, or that of a player or ball, and how integration and differentiation actually move you between them. Okay, so what do they do? So differentiation and integration enable. So differentiation and integration enable moving between, so enable okay, so this is more generally, this is what they do, is they move you between quantity functions and rate functions, okay? So, and I'll show you exactly, moving between quantity functions and rate functions. Okay, so how is that? And over time, we'll go through more and more precisely to the extent of what you'll need. Okay, so I have enough colors here at the moment to kind of do this. So I have differentiation. So we're going to start out with, so we have f of t might be a quantity function. How far did a player move? What is their position? How many goals did they score? Anything like this. It's outputting kind of a quantity. If you differentiate that, what happens, you end up with, and it has a certain notation to it, so I'm going to differentiate that, and then I'm going to end up with f prime of t. Okay, it's going to be a rate function. So this is going to be a rate function. Okay, so this will giving the rate of change of f with respect to t. So this giving the rate of change of f so the rate of change of f, and then, so you know that it's the word wondering how the function changes as we change t, for example, as we change time. Okay. And then if we wanted to go back in the opposite direction, then we would have integration would take me in this direction. Okay, so this, if I wanted to go this way, I'm not going to try to write upside down, even though the arrow goes the other way. So this is integration. Okay, so in our circumstance, or our favorite example, so in our favorite circumstance or example, so in our favorite okay, so let's start out with P of t being, so this is the position at time t. Okay, and then the velocity, so this is the velocity at time t. I am always short one color in life, particularly because this looks the same as green, but we're going to pretend it doesn't so that I have one more color. So A of t is going to equal, oh, those actually look mildly different, I think, today. So acceleration at time t. You possibly know about a car accelerating, so things speeding up, okay? So what is the relationship here? Let's just draw a line here to make sure that you can see that these things aren't melting together. Okay, so we start with the position. Okay, if I differentiate the position, so if I differentiate, then I land at velocity. And if I kept differentiating, I would land myself at acceleration. So if I differentiate position, I end up at velocity. If I differentiate velocity, I end up at acceleration. If I want to get from position to acceleration, I differentiate twice. Okay. Now if I want to go in the other direction, so we were doing that with red, and we'll continue that. So if I want to integrate, I get back to velocity. So to go from acceleration to velocity, I integrate, and to go from velocity to position, once again, I integrate. Now there are constants to keep track of, all these kinds of things, initial conditions, all kinds of things to keep track of. But basically knowing that differentiation is taking you to, the rate of change, and then the rate of change of that, and so on. So you go from position to velocity to acceleration. The other way around, when you integrate, you're going from a rate function to a quantity function. But here it's interesting because this is also a rate function. That's okay, but you're talking about like the quantity of the velocity when you're going from here to here, because this is the rate of change of the velocity, this is the quantity of the velocity. But now you're viewing velocity as a rate of change, just to be confusing, and then taking it back to quantity. Okay? But it really is it's really the relationship between two things at once. I put these all here because sometimes one actually has to differentiate or integrate once. And you're really going from some kind of quantity to the rate of change of that quantity, okay? And back the other way. So I hope that was at least a little bit illuminating, and I will see you in the next lecture.